Hi, this is Advanced Studies Algebra 2, Piecewise Functions, Day 1. If at any time the video is going too fast, don't forget you can always hit pause and go back to make sure you're getting all the information that you need. We're going to be looking at piecewise functions, which is, this might be the first time you've seen those. A piecewise function basically means that there's multiple pieces, multiple functions inside the function. So here we have two different linear functions, but we're not going to graph the whole line. This part over here is called the domain. So this is the domain in which we are going to be graphing this line. So we're not going to graph the whole line because this domain restricts us to only graphing the part where x is less than or equal to 3. So before we actually get to the graphing part, we're going to evaluate. So if it says f of 0, we need to find which one of these we should evaluate for 0. Well, we look at these domain restrictions again. Is 0 less than or equal to 3, or is 0 greater than 3? Well, of course, 0 is less than or equal to 3. So that tells us that we're going to be using this first restriction here. And so what we do is we put 0 in for x right there. Substitute it in. So we'd have 3 times 0 plus 2, which is of course 2. Now how that translates to the graph is this is your input, 0, and 2 is your output. Let's try it again with f of 3. So again, we need to figure out which function to use, which linear equation. So we have 3 is equal to 3 right here. So again, we're going to use this first linear function. So 3 times 3 plus 2, which is 9 plus 2 is 11. On the graph, that would show up as the point 3, 11. All right, now this last one, f of 6. 6 is greater than 3, so that's telling us to use this bottom equation. So we would do 6 minus 1. 6 minus 1 is 5, or the point 6, 5. So that's how we evaluate if you're given a value. Now let's move on to graphing. If you're asked to graph the function, you always want to start by evaluating this number first. So we're going to put 3 into this function. So 3 times 3 plus 2, we did that one before, so 3, 11. So on our graph, we can see that we're going to need to count by 2's in order to get to 11. Looks like on the x-axis we can count by 1's. It is okay to count by different things on different axes. So we're going to graph the point 3, 11. And since it's equal to, it'll be a closed circle. Now from there, we are wanting values less than 3. So like the next value would be 2. 3 times 2 plus 2. So 3 times 2 is 6, plus 2 is 8. So we would have the point 2, 8. We also know earlier we found that point 0, 2 is going to be on our line. So when we go to connect these, oh goodness, sorry, I was graphing and you couldn't see it. When we go to connect these points, this first point here, 3, 11, we're not going to go past that because we can't go any greater than 3. So instead of it looking like a line, it's going to look like a ray when we graph it. All right, let's try it again with the other piece of our function, this x minus 1. Even though it's not equal to, you still always put this number in first. So 3 minus 1, so we'd have the point 3, 2. And since it's not equal to, at the point 3, 2, we put an open circle. Then we need numbers that are greater than 3, so we could put 4 in. 4 minus 1, we'd have the point 4, 3. And then earlier we found 6, 5. Again, when we connect these points, it's going to look like a ray. not a line, starting at that open circle and continuing greater than 3. So you can kind of see why they might have called it a piecewise function, because there are 2 pieces of 2 different lines. All right, let's go on to the next one and try it again. So again, here we have 2 linear equations, 2 restrictions for the domain on that side. Let's start with this first one. Remember, we're always going to start by putting this number into this function. So 2 times 2 plus 1 gives us 2, 5. And then it's less than 2. So we can go ahead and put our 2, 5 on the graph. Sometimes I find all my points first, which is actually probably better. But these numbers are low enough I can tell that we're going to be able to count by ones. So I can graph the point 2, 5. But at 2, 5, do you see how there's no equal to sign right here? So 2, 5 is going to be an open circle. Then the next one, let's see, less than 2, so I'd have the point 1. 2 times 1 plus 1, 1, 3. You can also use your rules for slope and y-intercept. This has a slope of 2, a y-intercept of 1, so we know that the point 0, 1 is going to be on there. And if we have a slope of 2, we can just go down 2 over 1 instead of calculating. But either way is fine. You can calculate the points, or you can use your slope and your y-intercept. Just be careful with the open circles and the closed circles. And when you connect them, make sure it looks like a piece of a line, not the whole line. All right, let's take a look at this second one. We're going to substitute 2 in first. So we get the point 2, negative 1. It had an equal to sign, so it's a closed circle. You can find more points greater than 2, like 3, negative 2. And 4, negative 3. Or you can use the slope. It's just negative 1, so you can go down 1, right 1. And then again, connect it with a straight edge, but don't go past that starting point. So we're only drawing the arrow in one direction. And again, I assume I am going faster than you, so I expect for you to hit pause, make sure you get all the information, and then continue on. All right, our last one for this part. We get to see something a little unique on this one. Instead of having a typical linear equation that has an x in it, we just have the number 15. Okay, so 15, remember f of x is another name for y. So this is kind of like having the equation y equals 15. If you remember from Algebra 1, anytime you have a y equals equation, that tells us we're going to have a horizontal line. We're going to have a horizontal line at y equals 15. So to get up to 15, we know we're going to need to count by 2's. You can go ahead and label your graph appropriately for that. It says, and if x is less than 10, so we probably should label our y-axis by 2's as, our x-axis by 2's as well. So when we go to 10, we're going to have the point 10, 15, and it's not an equal to sign, so it's going to be an open circle. And then everything less than that is going to be 15. So 8's going to be 15, 7's going to be 15, all of these are going to be 15. So we are drawing a horizontal line heading to the left at 15. Okay, then we got to do our other one. So remember, we always substitute this number in first, so we put 10 in, And when we substitute 10 in, we get 10, 15. Well, we already had this open circle at 10, 15, but this 10, 15 has an equal to sign, so it should be a closed circle. So the rule is a closed circle supersedes an open circle. So even though that open circle was already there, we're gonna fill it in. Now we have a closed circle. We need a few more points here, so let's put 11 in. We need something greater than 10, so 11. It's gonna be 17. 2 times 11 minus 5. That's 16, 17. And then how about we do 12, 19. 12, 19. So that one is heading up and off our graph. Still only in one direction though. Do make sure you include an arrow so we can tell which way it's heading. And that's how we graph a piecewise function.